Hi, my name is Scott Simpson, and today we'll be talking about eigenfunctions. Eigenfunctions are a very important topic when it comes to physical chemistry because these scalar quantities are typically what you measure when you do some sort of quantum experiment. So, let's talk about eigenfunctions. If you haven't taken a linear algebra course, an eigenfunction basically it has an operator that operates on a function. You get a scalar quantity out, known as an eigenvalue, followed by that same function. So what it kind of looks like is you have an operator, acts on a function, and it spits out a constant times that original function. So, to kind of put this into symbols, we'll have an operator A. Most operators are given with a little hat that lets you know that it's an operator. Times our function, in this case we're going to use the symbol psi. We'll get out a scalar quantity K times psi. So psi should come back out. So again, A is an operator. It's going to act upon psi, and it's going to spit out a scalar quantity, assuming it is an eigenfunction, or assuming that psi is an eigenfunction of the operator A. So another important point is operators always operate from towards the right. They always go to the right. So operators act to the right. Psi, in this case, psi is an eigenfunction of operator A. And K is just some scalar quantity. This is also known as an eigenvalue. So, scalar quantity or constant or it's just simply known as an eigenvalue. Okay, so let's look at a couple of examples of a few different functions, and we'll see if they're eigenfunctions of that operator. Then if they are, we'll determine what their eigenvalues are. Okay. So let's do that. So the first one we're going to ask is e to the 2kx, where k is just a constant, an eigenfunction of the operator we're basically taking the second derivative with x with respect to x squared. And then if so, what is the eigenvalue? So we want to know what the eigenvalue is. So again, remember, we have some operator A. It operates on a function. We have to get a scalar out, or an eigenvalue, times that original function. Okay? So we have to determine if we get that original function back out. So let's operate on e to the 2kx. So we got b squared, dx squared, e to the 2kx. So we have to follow the chain rule with this guy. Let's just do the first derivative, and then we'll follow the second derivative. First derivative of this function, if we do that, what we're going to end up with, we get dx 2k e to the 2kx. Okay, have to do a second derivative on top of this. do that again. We'll end up getting 2kx times 2kx, so 4k squared e to the 2kx. Now we have to determine if this is actually an eigenfunction of that operator. If we look at that, we still have our original function. So that's our psi times our k. That's our constant, 4k squared. So we do this in fact is an eigenfunction of the operator d squared dx squared, or the second derivative with respect to x. So yes, it is an eigenfunction. And the eigenvalue is 4kx squared. Let's look at another example. The next two are a little simple, but I think they illustrate good points. We're going to ask the same thing for is sine x an eigenfunction of d dx? And if so, we have to determine what the eigenvalue is. So let's look at that. This is pretty simple. d dx of sine x. If you take the derivative of sine with respect to x, in this case it's going to become cosine x. So now we have to consider, do we get that same function back out? If we look, no we don't. So in this case this is not an eigenfunction of d dx. Let's look at one more example. Is e x to the third an eigenfunction of d dx? So we're going to take the derivative of e x to the third with respect to x. Again, we have to follow the chain rule. Doing that, we get 3x squared times e x to the third. Now you may be tempted to look at that and say, hey, we got ex to the third back out. Yes, it is an eigenfunction. However, if you look, we have that x located right here. The new function, this is actually the total function that we get out, which is x squared e to the 3x. This is a brand new function. Therefore, this is not an eigenfunction of the operator d dx. So, therefore, not an eigenfunction. d dx. Okay. So it's important to know how to look at these and determine if you have an eigenfunction or not. Because most wave functions, they actually have to be an eigenfunction of certain operators for them to work out properly. So if you have any questions, please feel free to email me or leave a comment below. Thank you.